Working. My name is Mark Shuttleworth. I work for Canonical. We're we represent Juju, which is one of the components of OSM. And so I wanted to just give you an introduction to that, why it exists in OSM, what it's doing today, and what the roadmap is effectively for that. Do we need to switch video? Is there a magic button? Yep. Got it over there? All right. Okay, so in the rest of the world, in the broader sort of cloud market, Canonical also produces something called Ubuntu. Ubuntu is a very widely used operating system in cloud environments. Something like 70% of the public cloud runs on Ubuntu. So this is a little picture of what's going on outside of telco, what's happening in terms of the stack and the innovation pipeline essentially in public cloud. So we had physical machines which turned into virtual machines maybe 15 years ago. And then the emergence of public clouds essentially introduced a new way of thinking about virtual machines, which was to stop treating them as kind of prickly individual things, but start organizing them in groups and shift essentially the way you achieve resilience, reliability, throughput, and so on by shifting to this cloud-native type approach, right? Then we saw a continued pressure in public cloud for more efficiency, more performance, and so on, and that led to the emergence of container machines. So those are even finer slices, effectively, of a machine, but they still feel like machines. We still call them machines, right? A LXD container, we've talked about using them in OSM. And LXD container feels just like a VM. It has an operating system, CentOS, Debian, Ubuntu, RHEL, but it's much lighter than a VM, effectively. And we're now in a phase where people are pushing even finer, and so they're down to the level of individual processes. There was a question earlier about Docker and whether OSM has considered Docker. If you go beyond Docker, you get into something called serverless, which is where you're really talking about a slice of time on a process. So all of this is what's happening on the public cloud, right? People are pushing the boundaries of how to organize software, how to run software, how to get performance, how to get resilience, efficiency, operational, all sorts of things in that stack. That's what's happening outside of telco. Now, image-based NFV is about here, right? Image-based NFV is still just let's take an appliance and make an image out of it. And that's important, right? That's essentially the reality of many VNFs today. If a telco talks to their preferred, traditional, established supply lines, they will get this, right? They'll get an image. But that's essentially pre-cloud. That's essentially just taking the box and turning it into a VM. And what I want to talk about today is essentially how we go beyond that, right? How we essentially get up into cloud-native architectures with machines and containers, and then potentially setting the stage for some of the questions we had earlier about, well, what could you do with Docker and so on and so forth, right? Okay, now that top stuff, that's still kind of crazy, right? There's nothing approaching a consensus for process container operations. Is that going to be Google's way of doing it? Is that going to be Microsoft's way of doing that? Is it going to be Docker's way of doing it? And the serverless stuff is still sci-fi, right? There's lots of people talking about it, but it's way out there in the crazy territory, right? But the cloud native story, the idea of organizing groups of machines and modeling that and driving operations that way, that's very well established. This stuff over here, this middle stuff, cloud-native machines and container machines, that's how Netflix operates, right? That's how Uber operates. That's how most of your PaaSes, Cloud Foundry, Heroku, that's how they operate. So this is fairly well established, right? So what are we talking about here? We're talking about essentially giving OSM the ability to work in that cloud-native way, but also providing some additional supporting scaffolding for what OSM does right now. And I'll talk a little bit to both of those. Okay, so the previous presentation essentially was looking at that top-down view of standing up a service. And I think this is a great thing about OSM, is that it's very much focused, if you look at the dashboard, it's really focused on, you want to get a job done, right? You want to instantiate a particular service. And you talk to Rift.io, that portion of OSM, when you do that. That's what presents you with that GUI or that REST API, right? So that's a human operator essentially saying, this is what I want to do. Rift will then talk to a resource orchestrator, and this is important to have separation here because that allows policy for the allocation of resources, which is very much a business decision for the operator. It allows policy for the allocation of resources. How much capacity, how big is the virtual machine going to be, and so on and so forth. Which cloud do I want that on, all of those sorts of decisions. Those are now taken by the resource orchestrator, which can talk to a Vim and stand up a VNF image, right? So this is how we would go about, this is how you imagine the flow happening if you have a VNF that is essentially a disk image from an old appliance. We don't actually do that. Potentially we add an extra step, right? And then you can imagine that Rift could just go to that image, just like you could go to a racked appliance and talk netconf to it, right? You could talk some sort of standard VNF appliance-specific protocol to that thing. We don't actually do that. We take an extra little step, which is to introduce this extra layer in the middle, the VCA layer, which is Juju. And when the RO stands up the VNF, it can also instantiate an ops code layer, right? A holding place for operational code. And that's what we call the charm. So what does this do? This is an extra bit of complexity, right? This is an extra moving part, and generally those come at a cost, right? You have to understand them, you have to debug them, and you have to work with them. What it really allows us to do is it allows us to have a place where we can collaborate quickly around operational code for things that otherwise can't be modified. That image there, that VNF image, can't be modified until the VNF vendor puts out a new version of the image. Right? That blob, that purple blob, the VNF thing, is, comes out once every couple of years, can't be modified until then. But having the charm, this is essentially a place to run code, and we can collaborate around the code, so we now have essentially a staging point. We call that a proxy charm, because when we talk to it to configure the service, we can go through that, and so now we essentially can aggregate what operators know about running that image, right, in a place which can evolve very quickly at the speed of code, effectively, right? So that's an extra hop that gives us that extra capability, even where we're working with the VNF image. We can also use those charms to talk to appliances. So, in fact, this gives us the ability to bridge some of the old and some of the new, and it gives us a place to hold purely operational code. Now, you also have operational code up here at the NSO, and the difference really between those is code which might be industry neutral, code which essentially applies to every industry or every user of that VNF, versus code that's getting more domain specific. Up here at the NSO, we really are thinking about telco issues, telco business priorities, and so on, right? So the great thing about Rift is that it's built for those kinds of problems. It speaks the language of telco. The great thing about Juju is that it doesn't, right? So we have place to aggregate knowledge that is not domain specific and a place to overlay on top of that knowledge which is domain specific. And that, I hope, gives you some rationale for why we have all of these pieces in OSM. Okay, so digging into the charms then, these are shared operational code. And having shared operational code is really important because of the human element of onboarding, right? Think about the process that institutions are going through. They're bringing new code into the building. They're becoming operators of software, right? And that means that you have a human skills development process. To roll something out, you have to have people who know what they're rolling, right? If we can aggregate operational code, we can simplify what operators need to know about that. So instead of knowing how to go into a specific VNF, instead of knowing the technical details about what to do in a particular VNF, or more importantly, when you've got multiple VNFs, topologies of multiple VNFs, we can start to produce a higher level interface that's essentially goal-oriented. It allows people to have a higher level view, to be trained on a higher level view. That obviously simplifies the process of bringing new code into the building, right, and reduces the friction and the overhead associated with the operational life cycle of a VNF. Charms are very focused on things that are not specific to a particular industry, right? The life cycle. How do I stand this thing up? How do I scale this thing? How do I upgrade this thing? And then operational code. How do I back it up? How do I know if it's healthy? Those sorts of neutral things. They also capture integration, right? The lines between pictures that you'll see here are all about saying, I want this application to work with that application. And Juju essentially has a very explicit language for letting us know if the vendors have declared that that can be done. This also gets us a step towards the new generation of cloud-native VNFs, right? This also gets us closer towards working with VNFs that were designed for the cloud. Obviously, we have an important collection of VNFs that existed as boxes, and we have a roadmap for them to become images and then to become, OSM onboardable images. But we also want to stimulate the growth and the investment by new players in VNFs that really are born for the cloud, right? And so that charms really give us a very nice language to describe those. So this is about these top two layers, right? Things that are cloud-native ways of operating pools of virtual machines and pools of machine containers. Not Docker containers yet, but machine containers. Now, the reason I think this is really important is because of SLAs. In the old days, you had a wire into a box and a wire out of a box. And you could measure everything going in, you could measure everything coming out, and most importantly, everything that happened inside that box was somebody else's problem, right? And one person's problem, the person who manufactured that box. Well, today, you have many, many layers in the stack. You have hardware that you bought from a vendor. You have a host hypervisor or OS. You have potentially a different Vim layer from a different vendor. Then you have a guest OS, which maybe you chose, maybe you didn't. Right. Then you have a VNF. And performance and reliability are a function of all of those layers working together. And one of the toxic consequences of working down at the lower level there with virtual machines is that you're getting an image that includes pieces that you can't modify. So as a result, you end up, like it or not, modifying the cloud. And we've observed this in numerous NFV environments where essentially people are saying, well, I need to tweak the cloud so that it will feed this blob, this image, just the stuff that it wants, or the stuff that it wants in a particular way. And this is, of course, violating one of the fundamental potential benefits of NFV, which is the ability to aggregate resources and then in a very agile way, evaluate and onboard different VNFs. If you have to rebuild the cloud for every VNF, if you have to adapt the cloud to the image, then you're not going to get those benefits. So we are in that world today, right? We see clouds getting built that are VNF specific. We see clouds being sold that are VNF specific, but those are really just scale out appliances, right? So to get to a world where we can onboard any VNF to any cloud, we really have to look into those images and start to operate the software in those images in a much more tractable way, right? The truth is, you can't avoid the complexity. We are in a software operations world. Running on the cloud is running software, is operating software. So that complexity exists. The only question really is your strategy to address that complexity. And the way the major operators have learned to do this, essentially, is to say, I want to consume each layer independently so that I can drive what I need from each layer independently. And specifically, that means typically you want to move to standardized guests. You will have Windows guests. There'll be some apps, some VNFs that you want that run on Windows. There'll be some that run on RHEL, CentOS. There'll be some that run on Ubuntu, right? And you can establish the relationships that you need to tweak, optimize, tune, and manage those guest OSs. That essentially gives you a strategy then to manage VNFs independently across any cloud, right? Because now you can essentially get in and look at the SLA requirements and look at the VNF requirements and deliver them on a standardized cloud if you can manage the guest OS effectively. And you'll see this pattern pretty much anywhere people are having to operate at cloud speeds, right? The goal of this is to get telcos to operate at cloud speeds, and so we're just looking ahead and saying, this is simply what you're going to need to do. Okay, so I want to do a little bit of a demo. Let's see if the demo gods are with us. We have some carrier pigeons and smoke signals between us and the internet, but that looks good. Okay. So this is a blank canvas. This is what I want to show you is just zooming into OSM, looking at the VCA and what the VCA itself is designed to do. If you just use the VCA in some other project, this is what you'd be getting. Now remember, OSM is wrapping a lot of workflow and support tooling around this. But I just want to zoom in and show you what Juju is all about. Now, I'm going to use some cloud-native VNFs. And I'm doing this actually on Google. So this model, if I go behind the scenes, right, and I say, show me what's running here, I've got a Juju controller. So there's a Juju controller as part of OSM. And I can ask it what models are there. And I'm logged into one called CRAN EPC. And it's a blank model. There's nothing there, and there's nothing here, right? This is the canvas, effectively. And so now I'm going to use a kind of a system administrator's tool to essentially say, here I've got, here I have a template, effectively, for a VNF model, which is a set of applications which are related to each other. So it's multiple applications that are essentially integrated to each other. And I want to go and spin that up on as it happens, Google Cloud. So I would do this. Now this is what OSM is doing behind the scenes when it stands up that operational code. So you'll see there's a database, that's MySQL, you might recognize that. Then there are a bunch of charms for an EPC and an HSS and an ENB, and some integration lines between those. And if I go and have a look at my canvas now, you'll see I'm actually getting those things. That's a CRAN, right? So here I'm getting the OAI, CRAN, and MySQL. And what I'm actually getting is a model of those things. If I go in and have a look at the status now that we looked at earlier, I'm going to zoom out a little so you can see more of what's there. You'll see those 4 applications. There's only one of each of those things. In other words, we're not scaling that yet, right? And that's spread across 3 machines, probably because I'm using containers somewhere in there, or I'm putting 2 things on the same machine. Oh, that's right. I've got MySQL and the HSS on the same machine, effectively. So that's why there are only 3 machines in there. Okay, so that's the beginnings of a model. Now, what if I wanted to deploy an EPC along with that? So I'm going to call that, I'm going to deploy a different VNF vendor. And so you'll see some more applications showing up into this model. Now these are 2 different VNFs from 2 different VNF vendors, and I've actually integrated. Now, this work is not complete, because what I should be able to do is draw a line between this cluster that I created, which is an EPC for a customer, and the CRAN, right? And once I've done this, I can do it again for a different customer. Again, this is what OSM is doing behind the scenes for you, right? This is embedded inside. So you're coming into the top and looking at network services, but under the hood, we need to stand up VNFs. And if those VNFs are cloud native, then this is how that is being used effectively, right? So again, I've got a different model that I've brought into this overall model. Okay, and that is all up and running actually. So this I was busy deploying on Google Cloud, but this is actually all up and running on AWS. And that highlights a very interesting trend that we see, which is that the disruptive VNF vendors actually want public cloud to be part of the story. They want enterprises. This stuff is designed so that enterprises can run their own EPCs, right? And they might do that on a public cloud. So there are benefits to that, to the operators, in tapping into a stream of innovation, tapping into R&D and things that are being done for broader markets than just the traditional telco market. Okay. So I can then go in, this is running on AWS, I can go in and I can say I want to scale, say, this E and B. And so I would say I want to add, say, another 2 of these. And what I'm doing is saying that on AWS, I want to go and deploy another 2 of those things. And if I switch to this picture, or switch to here, you can see, all right, we've asked for 2 more in the model. If you look here, you won't see any difference because this picture is independent of scale. But if you zoom in effectively and just look at that one, that E and B, E node B, right, you'll see that now I've asked for another 2 to be added to that cluster effectively. This is what it feels like to work with models. Okay, so digging in under the hood, right, we're modeling clusters of images effectively, clusters of applications, where an app is really scaled out across potentially many machines. We would do that for performance reasons, or we would do that for resilience reasons. We're also modeling the integration between those. And what's really important here is if you look at just what happens inside operators, integration is the biggest expense. It's also the biggest obstacle to rapid iteration, right? It's Andy said, you know, wouldn't it be lovely if we could just bring stuff into the organization and run it and it would work? And the reason it doesn't today is the integration process, right? So what this is aiming to get us to is a world where you can, in fact, just onboard and run, right? How could one achieve that? Well, if you encapsulate the integration logic at the vendor level, if you essentially say to vendors, I will not instantiate your VNF until you have done the work to integrate it with those other vendors in such a way that is shared across all of your customers. In other words, any of your customers that are running these 2 VNFs can integrate them just by drawing that line, right? So this is the really profound change. And I think in the long run, this is the thing that will make the biggest difference, is the fact that we can now push back to vendors the responsibility for that code. Instead of having integration code that's been written once to run in one place, we have integration or code written by the vendors and the communities operating a VNF that's run in many places. And we know that we get better software quality when we have reuse and when we have essentially open visibility on code that's general. We're modeling scale, so the idea that any one of those things comes in multiple, potentially across multiple machines. And if you zoom into that, that's a fairly complex process, right? If I've got 2 things in the one app and 4 things in the other, I actually have multiple lines of communication potentially. Those things all need to potentially know about each other. Everything on the right needs to know about everything on the left. That is the process, that's the sort of marshalling that Juju handles, right? So OSM at a higher level can say, I want those guys to talk to those guys. Juju and the charms from the vendors would essentially coordinate, for example, who's in charge, who's active, who's passive, what's going on at the coalface effectively. And that's all code produced by the vendors and encapsulated in the charms, or produced by communities and encapsulated in charms and then just reused essentially. Now, higher level code may well be custom per deployment, because at a higher level, integrating something into your OSS, BSS, into your business, you may well want to be customizing things, and you saw some of the capabilities for that in the Rift NSO type layer. But at the lower level, you want as much reuse as possible, right? This stuff should all be general. Okay. And where this gets us to in future potentially is that when we instantiate the operational code, we're also instantiating the VNFs. When I deployed these, right? Oh, that's all up, right? So when I deployed these, Google has a very fast cloud. When I deployed these, I didn't separately deploy any images, right? Because all of the VNFs there are just applications that are installed on one of a few standard OSs. So as long as I can get an image of the standard OS, I can then do all of the application level lifecycle operations and other integrations on top of that standardized OS. So I don't have any custom images in this topology. Of course, OSM will let you bridge those worlds. OSM will let you work with cloud-native VNFs, but also traditional VNFs that are image-based. Okay. I'm going to stop there and take some questions, just because that's the back of the key ideas of VNF application modeling, and the separation of any images and the operational code associated with those images. Any questions at that stage, at this stage? Hi. Yep, so Juju itself takes a REST API. That's a lower level API than the REST API for the NSO, essentially. If you're integrating OSM, you would want to be talking to the NSO, essentially. And the NSO would be, and the RO together would be driving the model inside Juju. But you could tap it fairly easily. You could go and look at it, watch it. And one of the active areas of conversation in OSM is to say, okay, how can we allow people to integrate, for example, custom monitoring or management or assurance type services to the model in a way that doesn't interfere with OSM's ability to manipulate the model over time. Does that make sense? Yeah. Yes?
Do you care about the topology of the connected things? If we have one VNFM, another VNFM, and we wanted to have the certain topology to connect it.
Juju cares only at the level of describing what L2 and L3 networks they should bind to. So if you look at an example of something that's multiply connected, right, if you look at that Fabric app in the middle there, that Fabric app is integrated with SGW, MME, and PC, with all of them, right? But it may be integrated with different of them on different networks. So there may be an admin interface, which you want on one set of networks. The same daemons, the same pieces of software may expose other APIs or other integration points, which you want to map to different networks. Juju would care about that. You can instruct that Fabric app to say, look, bind this interface and anything that connects to this interface on this network, bind that interface and anything that connects to that. That's the level, that's the only level that Juju would really care about. The NSO and RO together would deal with things like routability, connectability, traffic flows, and so on and so forth. Does that answer your question? Yeah. It's a great mic. It's really performs very nicely. Your questions echo out. They may even be captured on video forever. Okay. All right, so what's the structure of this? Now, again, this is nested inside the broader descriptor package that we were talking about earlier. So the broader descriptor package at the NSO level has a subdirectory, effectively, a subcomponent, which is this operational logic associated with a VNF, or what we call a proxy charm, operational logic associated with an image, right? So what does that look like? Again, it looks like a fairly clean set of descriptors in YAML, metadata effectively, and then a set of executable hooks, we call them. They're really just lifecycle events, binaries that get run at particular points in the lifecycle, and they get fed information. So those hooks deal with things like lifecycle events, scaling events. Now there's 2 of you, now there's 3 of you. Integration events, please integrate with that app over there, please integrate with this app over here. And configuration events, right? So those are all dealt with by essentially binaries that are produced by a community or by the vendors. So digging in, that's what a metadata, the high-level metadata looks like. The stuff at the top is essentially just descriptive. This stuff is more interesting. This is where we're starting to describe the fact that these 2 things are allowed to be integrated, right? They both provide and require essentially a common interface, the S11. So one of them provides S11 and one of them consumes S11. And this is an endpoint, SPGW. So this is a provider of S11. MME is an endpoint on a different charm. This is obviously one charm, so it doesn't show the other side. MME is a different endpoint which consumes the same interface. So the fact that these two charms declare one provides, one consumes this interface, the same name, Juju doesn't know what that interface means. It's just permission to allow those things to start exchanging messages along that line effectively, right? So an interface, for example, would be something like HTTP. In other words, these two things can exchange messages about an HTTP conversation. But I may have an admin HTTP interface and a consumption HTTP interface, right? In other words, I've got a REST API and I've got a web interface. Those both speak HTTP, but they serve different functions, and I want to integrate different endpoints with them effectively. So that's a declaration of that. Here we have lifecycle events, right? I need to install the software. Remember, one of the key ideas here as we get to cloud native is by essentially saying that what you've got in the VNF is the actual application, which is supposed to run on one of a minimal number of trusted, supported, certified OSs, right? By decoupling those, right, we essentially allow us to get in and debug and manage the guest OS, which allows us to take control of performance and SLAs, right? Otherwise, that becomes an impossible problem. Otherwise, you have to modify the Vim to suit the guest, right? So here, because we now have decoupled the app from the guest, we need to install the app on the guest. And so that's what the first of those hooks does. We have hooks for things like leader election in a scale-out environment. Which one of those is the one that we should deliver messages to which are about the whole application? Think of it that way, right? So you have a database. When we want to back up the database, we don't want to go to both copies of the database and back them both up. We want to go to one of them, that's the leader, and say, what should we do now? It may send us to a different one to actually do the work, but essentially we always want to start with the leader, and Juju supports leader election. It's a very common problem in cloud-native operations. We want to configure those things. We want to deliver them a nice new view of their configuration. We want them to translate that down to the actual configuration files that they actually use in etc. something. And we want to start and stop them, and we want to tell them about each other, right? That's all sort of lifecycle stuff. If I get a second database node in the cluster, I need to tell the first one, and I need to tell the second one that it's the second one and where the first one is. I need to tell them both about each other. So that's that set of hooks effectively. We also have hooks associated with integration. This is the message passing idea. When the line gets drawn between these two, remember it can only be drawn between these two because the charms from the vendors or from the communities declared that they should be able to exchange messages. Well, what does exchanging messages actually mean? It means we're running these fragments of code, right, on both sides, one after the other, and they're passing messages back and forth until they tell us that they are integrated, right? So of course, you can have charms that claim to be integratable, but they have bugs. The good news is those bugs are the vendor's problem, right? What you're essentially doing is saying that, look, if your charms say they can integrate and they can't actually integrate, then that's a bug in your code, not a bug in my operations effectively. So this is that profound shift from the operator's point of view in pushing back responsibility for integration to the vendor community or the operator community as a shared problem. And so this is the sequence of things that need to happen, right? When I relate this application to this application, remember, it's actually multiple instances of the database, multiple instances of the app, or vice versa, whatever's on the left and the right. And they all have to exchange messages until they're all happy that they know what the other guys are doing, what's happening, and why it's happening effectively. That's the work that Juju coordinates. Rift doesn't have to worry about that because that's in the model effectively. Okay, and then we capture operational actions as well. And these are not related to the topology in general. They are VNF specific, or application specific. So think of all the things that an expert operator knows how to do with a piece of software, right? They know how to go to the box and find the right config file and then stop the thing before they run an action, because if you run the action, while the thing is running, then you have problems. All of that expertise, all of that knowledge, that can be distilled down into these action hooks, effectively, which can now be called by anybody. And we see lots of good examples of this helping organizations bring VNFs and complicated software into their organization. Because now all of the training, all of the documentation is at this higher level view, and essentially it looks the same for every different piece of software. How I list the actions, the things I can do for a database is exactly the same as how I list the actions, the things I can do for a PE router, right? And so operators now have a much more constrained set of places they need to go to look at things or take actions. And similarly, the NSO now has a much more clearly structured view of anything that comes into the system that's encapsulated in this way, in this format. And much to my delight, that's the end of the deck. So, we're ahead of schedule, which is great. And another question. Do you want to just yell it and I'll repeat?
So actions, I assume that they are, you have a base set of base actions, I guess, part of Juju, and then it's also part of
Yeah, the base actions that you're describing are essentially lifecycle and integration based. In other words, every app has to get installed and removed and upgraded and configured and integrated with other apps generally. So those would be common hooks that you would find in each charm. These operational actions will tend to be more specific to a particular VNF. Like this is a database, so I happen to be able to vacuum this database. Instead of training someone to know that you SSH to this thing and then make sure that it's not the leader, and then you type this command and then you go over to the leader and type a different command, this high-level action will encapsulate, do all of those things, right? There are patterns that emerge for operational actions that you find across multiple VNFs. For example, if we look at the Vim world, OpenStack, and the multiple charms from multiple different vendors will often implement, for example, a pause action. What do I use that for? Say I've got a scaled out thing and I need to do some operational work on one of the units. I often want to tell all of the other units that guy's going away for a little while, don't use them, but also assume that he's coming back. A classic example would be software-defined storage. You've got 3 copies of every file spread across a big cluster. If you lose a node, you now only have 2 copies of all the files that were on that node. So the software-defined storage often has a mode where it goes into to sort of reproduce a 3rd copy of all those files, which is a lot of network I/O. Well, if I'm just essentially rebooting that machine for some other reason, I can now pause that. That tells everything not to panic when that disappears, reboot, and resume. And that's a pattern that you'll see across hypervisors and a bunch of other types of VNFs, things that you'll have to operate. So we do see common patterns that are operational patterns encoded as actions. That's very nice because people sort of don't have to be trained. They know instinctively, okay, I pause that before I do something else, right? And they know what it means. But generally, these are VNF specific. Does that answer your question? Yes, another question. Yes.
Point of view. Do you have some kind of
yes. Well, first, I think right now, Juju plays a nice role almost as think of it as the process of racking and stacking appliances, right? I need to give them management IPs. And I need to tell them about, for example, that's where to send their logs, and that's where to send their SNMP traps, and that's where to, and all of that happens before I start essentially configuring services. So in OSM as it is today, in fact, if that VNF speaks netconf, then once it's stood up, Rift would talk netconf to that VNF, right, for the service level configuration. Now, clearly there's some gray areas and potential overlap there. We are looking, I think we can learn from netconf and provide cloud native stories there. But, in the journey of adoption, there will always be some things which are still old pre-netconf images, then there'll be some netconf images, then there'll be some cloud native things that speak netconf, and then there might be some cloud native things that just speak cloud native service configuration. And working with Rift and the other collaborators in OSM, I'm pretty sure we can address that curve. For today, the best way to think about it is Juju is essentially handling the app topology and layer configuration, and Rift is handling service configuration. Here's how I stand up a router. Here's how I configure a VPN effectively for that customer on top of that.
Mark, how do you handle failure in any of those actions? Do you have to pre-plan all the possible way one of those actions may fail and associate actions to those failures?
That is the voice of experience speaking. Failure is inevitable, right? The way we handle that is first Juju will keep track of, for example, an error in an action or an error in a hook. It'll tell you that there was an error. And then one would go in and manually try to resolve that. But more importantly, remember that's shared code. And so we are all sharing the burden of increasing the quality of the code, right? So as I think you know, ops code ultimately deals with things that are very hard to predict, and often you will run into a new situation, corner case, race condition, so on and so forth, right? What you really want to be doing is sharing the cost of essentially codifying the world's best expertise and the world's best operational code. So that's what charms give us. They don't magically, essentially we can't magically guess how to react to a failure, right? If operational code from the vendor crashed, we can say that code crashed. But now what we can do is we can file a bug in the vendor bug tracker or the community bug tracker around that, for which all the people are sharing, and that can be debugged, and we're sharing the cost of that, right? So this is how ultimately we lead to fewer failures and better quality operational code, right? Does that answer the question?
I hope you had a magic silver bullet, but...
No. There are obviously ways that charms can be written to be more resilient, more transactional. What you're describing essentially is the journey of software quality, right? And I'm much more of a believer in how you get to quality, right? And especially how you get to quality benefiting from a broader community, right? Participation in a broader community, right? Right. Thank you very much.